yeah, I think in order to get started, we've got to talk about the company, we've got to talk about the founder, and that is me in this instance. I, like Mr. Combs said, I've been in the tech area of this school for quite a few years now. I did intro to programming my freshman year, and then I did 2 levels of CAD with Mr. Combs in sophomore year and junior year. I have my CSWA and CSWP, which are industry level certificates in SolidWorks and 3D drafting. And in general, I would just describe myself as a very excellent, terrible student, in that I am in a lot of high-level classes, I do a lot of high-level work, and I am an awful student the entire time. I'm not good at planning out projects or anything like that, and so that is where I decided to focus this class. I signed up for this class because I, being the supreme nerd that I am, considered this to be my for fun elective. I signed up for this class because I wanted something fun to do on my off time. And so I decided that I would want to learn more about coding and math and video games because I like all those things. And so I decided to make a video game. Another part of why I chose to do that is because, as I have been in the last 12 years of my schooling, I procrastinate a lot. And you can't do that with this type of project because the sheer scale of it doesn't allow for procrastination. You can't produce an entire game in 2 weeks. It's just not feasible. You have to make all the connections work in between everything. The volume is just too large. So this would force me to actually plan something out over a whole year and complete it. My expert advisors. Part of this class, as Mr. Combs said, we got to reach out to industry professionals to try and get some real world networking experience, as well, just to get some advice from people who actually know what they're doing and not just stumbling blindly by ourselves. So my expert advisors were Crash Johnson. He's a database architect at Northrop Grumman, and he has experience in game development. He helped me right at the beginning of my project to get my head on straight and not get lost in the sea of possibilities that surrounded me. Just narrow it down to a single idea and keep moving forward with that. Tyler Sheets is a programmer working at Northrop Grumman as well, and he was my support for the technical side of things. I am pretty good at logic in code, but I have never really compiled something so large before that all had to work together. So I asked him my questions about structuring, if I should load and deload each individual room as your character moves through them, all that kind of stuff. And that was super helpful because I had no idea how to answer those questions on my own. My support advisors were my parents, Brian and Heather McRae. They will keep me motivated and kick my butt anything needed. I wrote that earlier this year. It actually wasn't needed, thankfully. And they are industry professionals, and they work at Northrop Grumman, and so I could consult them when I was having issues with problem solving. Robert Bond is my best friend since I was like 3, and so I'm going to constantly ramble and complain to him when my code isn't working. So I feel like I had to put him on there. He gets credit for that, just dealing with me the whole time. And then my younger brother, Braden McCrary, was going to be my quality assurance department in primary play testing. This image is the map of 112% completion of the game Hollow Knight. Hollow Knight is the game that I got my inspiration for my game idea from. This game, I love this game. I completed it almost to full completion. It's too hard for me, I can't actually do it. And it took me about 48 hours to do so, even though it's a 2-dimensional little platformer exploration game like I've got going, except on a much, much smaller scale. All right, in this project, I want to continue to develop my coding skills primarily. I'm planning on going to college and getting a bachelor's degree in mechanical engineering, but I don't want to lose the computer science side of things. So even though I hadn't taken a programming class since freshman year, I took AP Computer Science A this year, and I'm doing this as my project to try and keep going in the coding and not lose that. I also wanted to create a genuinely polished product. I wanted to finish something and be done and proud of it at the end. I want to become more fluent in complex computer logic. I want to be able to just move through it quicker because doing loops and stacked if statements takes forever if you don't have enough time doing them, and this way I can just do a bunch of them all at once. And also I was hoping it could help me make a career decision because, like I said before, I'm kind of stuck in between engineering and computer computer science right now, and I lean both ways all the time. And as I mentioned earlier, time management is not one of my strong suits, so hopefully it would improve throughout this. This is my logo. I decided to name my company Low Speed Games. I deliberately did not make it sleek and futuristic looking because I don't like that trend in logos, and I wish that it wasn't a thing. And also, it's a callback. It makes the logo very easily recognizable. The arrow keys are the keyboard and also in the same shape as Tetris, a Tetris block, which might be a bit of a stretch, but it is the most popular game of all time, so I think it could get in there. As well as Low Speed Games, just the irony of it makes it memorable because in today, especially, technology just keeps getting faster and faster and faster, and so I just thought that the name made it stick out. All right, here's my initial timeline. This was made very naively. My past experience was in freshman year. I used a game engine, if you could call it that, called Arcade. And basically I coded my entire game by hand, and it was just develop one thing, move on to the next, so on and so forth. So I didn't put any R&D time into this, or research time into this, and it was all just create a character, make him move, have physics work, blah, blah, blah. And that was basically it throughout the whole thing. I just slowly moved from creating the character to creating tools and abilities and enemies and connected rooms and maps and so on and so forth. And then at the end, I thought I would have 3 months of just slowly increasing the scale of my project. That was not accurate at all because, like I said before, I had no experience working with a real game engine. And Godot, which is the engine that I ended up working with, which is an open source game engine created by students at MIT, allows you to create a game without doing so much brute force, blunt coding. It knocks out a lot of the repetitive, unnecessary work and just allows you to go straight into the development aspect of a lot of it by helping you with certain building blocks and tools. And those are powerful tools, and those needed to be understood before I could even begin to use them. So instead of going straight into the game like I thought, I had to learn to walk first. And so the very first step is the most instrumental tool of Godot, nodes. For those of you who are programmers, nodes are basically objects. They're pre-constructed objects that already exist in the software, and you can use them to assign certain characteristics to more complicated objects that you create. So you can stack nodes on top of each other, like this, for example. My player character up here, and this is the one that's in the final game, is a kinematic body, which means it is affected by physics. It has an animated sprite, and that's just what it looks like. And it's got a hitbox that's made out of 2 collision-shaped 2Ds because it's not just a rectangular circle. I wanted a more complex shape. And there are dozens and dozens of different varieties of node for positioning GUI, for allowing different interactions between different physics objects. The possibilities are really stretched forever. So you have to spend some time getting familiar with this before you can start making anything. Scenes are what those stacked node configurations are called. For example, this is a coin scene in a game that I made off of a tutorial in Godot. I can use this coin scene as an object in other scenes. So if I were to create a main game, I could then put 1,000,000 coins in it, and each one would have all the properties of this coin scene, which includes an appearance, an animation, collision, sound, particles, so on and so forth. And that's how you can just allow for incredible complexity in such a simple setup. Here is the main game of that. This is, again, Godot assets, a Godot tutorial. And here is, this is the whole game spread out. It doesn't look like this while you're playing it, but you have this whole level with a parallax background and like 3 dozen coins, or probably not 3 dozen, but a bunch of coins, doesn't matter. And all of them are just copy and paste this and put them in different places in the world. Scripts is Godot's coding. It's just GD script is its own native language. It's very similar to Python, and luckily I have had experience in Python before, so I was able to pick it up rather quickly and then just move on from there. Signals. This is the real meat of the research, because nodes are useful for building an individual object, but in order to get the objects to talk to each other and actually do something, you need to rely on signals almost entirely. It's just by far the most efficient way to do it. And so connecting the unique signals from different nodes to all the other things in the game is what allows for complex interaction, like a character taking damage from an enemy or moving through a different room and being teleported into the next room, stuff like that. Basically, any function is necessary to connect to the signals. You can also manipulate signals through the code. For example, here, this is in the original tutorial game I made. When a player gets hit, when the player body is entered by a foreign physics body, which this green thing means that this is being told that by an outside signal. So when the player hitbox detects something entering it, it emits a different signal, and that signal then triggers game over in the main scene of the game. So these are like internal different notifications, and it's basically just the different objects in the game yelling at each other. Okay, so my first steps. This is the first tutorial game I talked about, Dodges and Creeps. It's a simple little portrait phone web game. All it is you're this little dude right here. You can move in this space, in this two-dimensional space, and enemies will spawn in around the edges in random locations and go in. This was just to get my bearings in the system and get moving. And then here was where it really started. Wait, this is not the right order. There we go. So this is my second proof of concept game. This is the one I mentioned earlier with all the coins in it. This is the second tutorial I filled out. This one had more complex assets, and it was actually the type of gravity that I would have in the real game, which was helpful. And then I started really developing the actual game moving forward. This was the initial testing map. Here is where I would put each individual element as I created it, so that hopefully I could test each element by itself, and then when I put them all together, they would work and not hate each other. It didn't really work, but it kind of worked, so I'm still happy with it. And this is what the game looked like at that point. All right. The very first thing I set up was the player character. Your player character is obviously the primary interaction with the game. If it doesn't feel good, the whole game is going to feel bad. The movement needs to be unique. There needs to be acceleration and deceleration on both ends of the movement, because even if you don't know the rates at which things accelerate in real life, your body and your brain are just so used to seeing things move like that anything that doesn't automatically feels wrong. So I had to make it so that your character would move and feel sharp and quick in response to your button inputs, but also obviously slow down before stopping and speed up before getting to top speed. And that was a little bit of a balancing act. And then in a more fleshed out, developed game, the player character is the heart of the game. Without the player character, there is no interaction with the game, and therefore it doesn't matter at all. It's not a game after that. So this was obviously step number one. This was pretty simple. I just made a character. There was nothing for it to interact with, so I couldn't really mess it up. And then we moved on to enemies. For my enemies, the biggest problem is collision. I wanted them to bounce off of walls in the game, but not bounce off of the player and actually hit the player. So I ended up actually having the enemies not collide with anything at all, and have them send out little ray feelers. Ray being arrow. Have them send out little feelers just beyond the surface of their hitbox. So if they ever get near to a wall, they'll flip and go the opposite direction to try and avoid ever colliding into the wall. So once I added the enemies in, as well as the player, that's when I started to, and inheritance structure. That is not good. Anyway. And I coded my enemies in an inheritance hierarchy. And what that means is, I knew that my base mob level enemies would have a lot of characteristics in common across all of them. Like they'd all have the same health functions, an ability to detect collision, an ability to take damage from the player and give damage to the player. So I put all of that code in a single box, and then every single enemy that I would create from that would refer to that box in order to know its base stats. So basically, an inheritance hierarchy like that is essential for further expansion, and will make it so that adding more enemy types into my game would be much, much easier. All right, enemy-player interaction was the first big issue that I ran into, because this is when I first started to interact with the way I wanted the physics in the game to work, and the way that Godot wanted the physics in the game to work were not the same. So the enemies would see the player as a wall and just stop just short of the enemy or the player and flip directions, or the player itself wouldn't allow the enemy to enter its hitbox because it's a solid object in the game, and so it can't allow that interaction to happen. So I ended up putting the enemies on a different collision layer, which means basically that they don't exist in the same space as the player. It's as if, since it's a 2D game, it's as if they're in the window behind the player and they can just move right behind them without touching them. And I put a second hitbox over the character that was just there to scan for enemies at all times. And if it ever did detect an enemy, then it would interact and send the signals to do health and damage to different things in the game. That is where the issues come in. The first issue was obvious. An enemy would come up to the player, and as soon as they entered that hitbox, your player would die immediately, no matter how much health he had, because for every frame that the enemy was inside the player's hitbox, he would take damage. So I had to make it so that the player was briefly invincible after he got hit for a short amount of time, and that when the player got hit by an enemy, it got knocked away from the enemy so that the hitboxes were no longer colliding. And that was an absolute nightmare to code. So this is after finally getting it all right, but basically the way that my velocity had worked up till now was the player's velocity was stored as a vector in the game, so I had an X component and a Y component, and I just had it basically clamping the X velocity so it could never exceed whatever it was. I think it's 300 pixels per second or something like that. And it would just flat out prevent it from speeding up beyond that and prevent it from changing speeds too quickly or anything like that. But that doesn't work with the knockback because I wanted to get a sudden jerk backwards. And basically I had to restructure this whole thing and pull it out and redo it. And I had to do a really deep dive into the Godot documentation to figure out all the math functions they had, because I needed to basically create a logarithmic, not a logarithmic, logistic function, like the increase on E, but backwards, and then that's not important. Anyway, it ended up in being velocity moved towards zero, but this is a really, really simple way to do a lot of evil math. And I was grateful that I found it, because doing it by algebra at the beginning was not going to work. All right, the major issue number 2, I actually didn't get a screenshot of this foolishly, but my enemies would go into the wall tiles and they would get stuck inside of the tile, because I had the arrays that were looking out for walls pointed in perpendicular degrees directly north, south, east, and west. And that was allowing it so that the perfect rectangle could slip in and fit perfectly right in between the angle and just get the center of its hitbox inside of the block. And then from there, it was just trapped eternally inside the block, bouncing forever. Luckily though, this was much easier to fix. I tried to offset every ray a little bit like this, so that the perfectly square rectangle could not fit into that pixel anymore. It's not getting slanted like that in the game. But that one was sitting there for like hours before I figured it out. It was very miserable. All right, and now integration and implementation. Stage 0.5, because at this point the game is barely a demo, and I do plan to continue beyond this. But at this point, it was time to put all the elements that I created together into one functioning whole. The first issue, signals are really weird. When I tried to do signals from certain nodes to alert the main functioning game of something, it wouldn't work, and I had to restructure the entire game. I can't really get bogged down into the weeds of that, but basically I spent 30 minutes re-parenting and childing all the nodes and restructuring the whole thing so that they could actually talk to each other. And then I got to spawning and despawning enemies, because I didn't want enemies to be in every room and all bouncing around and the game to be calculating all that all the time. So every time you exit a room, I would have a bunch of things happen, including moving the character and calling despawn methods or spawning methods when necessary in order to manage the placement of enemies and your player throughout the thing. And also, I had to affix a camera to the game, because by default, Godot tries to center on your character, and follow that around all the time with the camera, which would be absolutely terrible in this type of game because you'd be seeing outside the walls all the time. So the same thing here, this logic where if a room hitbox, if a room zone that I designate detects that the player has left it, it'll do a lot of teleporting around. Like it'll move the camera one room unit over, and it'll move the player a small jump over because I have to put space between the rooms so the player can be into it once, and a million little things like that. And ultimately, it became this huge mess of functions and if statements, and it all works out at the end. This is where we're sitting now. This is the full scale of the game. All of these rooms are running that logic that I mentioned earlier. These blue boxes are the room zones that are looking for when the player leaves. The eyeballs are invisible. You can't see them both because the camera never shows them, and they're just not visible in the base game anyway. And those are there purely to prevent the enemies from floating off into space, because I don't want them to just wander off through the doors and then never be seen again. And you have the ability to explore through here. There's branching paths. This is very secret looking here, but I promise it looks normal in the actual game. This is a secret door that you can break down with your melee weapon to get into to access a secret upgrade. And that was where the game stood after all of that. And then I need to implement the GUI so that people can actually play it and understand what's going on. So, health bar. The health bar I decided to go with heart canisters, kind of like Zelda games if you've ever played one of those. And I attached it to the camera node so that it would always be in view no matter what. It just, that way I didn't have to think about the positioning of it ever. And it turned out to just be a simple loop. I actually went to Godot Recipes, a website, to find this concept, and then I used it for my own thing. But basically it has a couple of textures, full heart and empty heart. And it has a simple loop where it goes through and it'll count up your health. So the player's health will be the amount of hearts that it displays on the screen, and then for the player's max health will be the amount of The player's max health will be the amount of hearts that are shown on the screen, and then the player's current health will be the amount of hearts that are filled in red currently. And this just gets updated anytime the player detects a collision with something, whether it be helpful or not helpful. All right. Oh, yeah, this is my bibliography. Are there any questions? I did in the games, the tutorial games. I just implemented the sound, but I didn't have time to implement my own art assets in this. I wanted to create art initially for it, and I will eventually, but it's just not realistic within the time scale I have for me to create art because I don't have those skills. I just can't do it quickly. Angelo?
Can I play your low-speed game high-speed?
I mean, I think it's like 60 frames per second. Is that high speed?
Can I fix that? High-speed, no.
Was it standard boss or bosses?
There was a boss. I don't know why it's not in this presentation actually. But yeah, I also added a health buff that would increase your maximum health, a damage buff that would increase your damage, and a final boss to act as the end of the game for now with the circuit. This presentation is not complete evidently, so sorry about that. George.
So you said there's logic for every room to check if you've left or whatnot.
Yes.
How computationally heavy is that operation?
It's not. So I have each room defined by an area node in Godot, and those just keep account of all the bodies that are inside of them at any time. So whenever it goes one lower, it automatically stores a little bit of info that tells you the name of what the body that just left was. So checking if that body was the player or not is nothing, basically, in terms of data. Obviously.
You said that you'd used another game engine before. Which one did you like more, the other one or Godot?
Godot. Arcade, I have learned, was supported by one college professor in Montana who kept it up in his free time. and it basically contained like 2 or 3 methods for animating sprites, and the rest was all just raw process code, which took forever, and I ended up with a game less than half this size with more than double the code. Impressive.
Because I think it's kind of funny. Remind everyone how much health you gave that boss.
Oh yeah. So the base weapon does 1 damage, and so your little mob fly has 2 health, and the boss has 30 health. So it takes 30 hits to kill the boss. If you don't get the weapon upgrade triples your damage, so then it only takes 10.